Hello guys, myself Ratul Dotto. Today I am here to present the retail sales prediction project. It is a capstone project and it is done as a solo project. So the project summary. The project aims to predict the daily sales of 1115 Roseman stores across Europe for up to 6 weeks in advance using machine learning regression model. This model takes into consideration various factors that influence store sales such as promotions, competitions, holidays, seasonality, and locality. This dataset is a live dataset of Roseman stores. Here is the GitHub link for my project. Here is the problem statement. Roseman, a retail chain with over 3,000 drug stores across Europe, faces the challenge of accurately predicting daily sales for each store up to 6 weeks in advance. The accuracy of this sales prediction is crucial for efficient resource allocation, inventory management, and overall business performance. However, predicting sales accurately is a complex task influenced by various factors, including promotions, competitions, holidays, seasonality, and store location. The goal of this machine learning project is to develop a predictive model that forecasts the daily sales for Roseman stores by leveraging historical sales data and considering factors such as promotions, holidays, and other external variables. We aim to build a robust regression model that can provide accurate sales forecasts. For analyzing of the data, we need to import some libraries such as NumPy, Pandas, Seaborn, Matplotlib, Sklearn, preprocessing, and etc. etc. So let's mount the Google Drive so that we can access our dataset in this project. Here is the first view of the dual datasets. It is the rows and columns count for the two datasets. Our Roseman dataset has contains 10,70,209 rows and 9 columns, where the stored contains only 1,115 rows and 10 columns. Here is the dataset information of the Roseman dataset. Here is the dataset information of stored dataset. So both the dataset contains zero duplicate value, and in case of missing or null values, Roseman dataset has zero null values while the stored dataset has some null values. So this try to understand the variables. The Roseman dataset has those columns like store, day of week, date, sales, customers, open, promo, state holiday, and school holiday. Here is the dataset description. Here is the variable description, like the state column indicates that the category for the 50 states, account length, that the how long the account has been active, area code, the code number of area having some states including each area code, and etc. etc. So here is the taking unique variables for each column. Next is the data wrangling. First, we need create some copy of the dataset, and next to fill the missing column values with 0, and again check for the any missing or null values. So here we can check that there are no missing or null value is present. And next is the merge the store dataset and the Roseman dataset. Here is the merged datasets first view. It is the bottom 5 column. Next, change the data type into the date time format. Here is the date column, then it is changed into date time format. And then the categorical value into the numerical value. State holiday has 3 values like 0, A, B, C, and those 4 values were changed to 0, 1, 2, 3 for building the machine learning model, and also change the assortment value into the numerical value. Assortment has A, B, C categorical value, while the it is changed into 0, 1, 2 numerical value, and also it is also applicable for the store type and here the competition open since month named column has changed into date time format, and the float integer present in the column is also changed to integer. So here is the all the detailed description of the manipulation that is done on the dataset for better analyzing of the dataset for building the machine learning model. Here is the data visualization and the storytelling experiment with charts to and better understanding the relations. Here is the data visualization and try to understand the relationship between the variables. Here is the first chart which describe that there are more sales on Monday, probably because shops generally remain closed on Sundays, or it could be seen that the promo leads to more sales. Normally, all stores with few exceptions are closed on the state holiday. Note that all schools are closed on public holidays on weekends. A equals denotes the public holiday, B denotes the Easter holiday, C denotes the Christmas, and 0 denotes none. Lowest of sales were seen on the state holidays, especially on Christmas. So on an average, store type B had the highest sales. More stores were open on school holidays than on state holidays, hence had more sales than state holidays. So next, here is the chart that is plotted between the sales and competition open since year. So from this chart we can conclude that the sales of the stores is affected, which continues the promotion. If the promotion is higher, then the sales will be more. If the promotion is lesser, then the sales will be less. Next, the graph it is plotted between the sales and the competition open since month. So the sales have been growing steadily over time. The ratio of growth has been slowing down in recent years. There was a slight decreases in sales in 2020, but sales have rebounded since then. So in the next chart, here is a 3 pie charts. From these pie charts, we can conclude that the majority of the stores are physical stores, around 53.9%, and there is a small percentage of online stores which is 13.3%, and there is a small percentage of other type of stores which is 2.7%. So the next chart, we can see that there is a chart which represents that the distribution of the sales is skewed to the right, and there are a few stores that are very high sales. The average sales are around $100,000 and the median sales around $50,000. And in the next chart we can see that most of the stores remain closed during the state and holidays, but it is interesting to note that the number of stores opened during school holidays were more than that were opened during state holidays. Another important thing to note that the stores which were opened during school holidays had more sales than normal. Sales are significantly higher during school holidays than during non-school holidays. The difference in sales between school holidays and non-school holidays is greater for winter holidays. There is a smaller difference in sales between school holidays and non-school holidays for the summer holidays. And in the next chart, we can visualize that the most of the stores remain closed during state holidays, but it is interesting to note that the number of stores open during school holidays were more than that were opened during the state holidays. Another important thing to note that the stores which were opened during school holidays had more sales than the normal. Sales are significantly higher during school days than during non-school holidays. There is a smaller difference in sales between school holidays and non-school holidays for the summer holidays. So from the next chart, we can visualize the graph and conclude that the stores that run promotions have significantly higher sales than the stores that do not run promotions. The difference in sales between stores that run promotions and the stores that do not run promotions is greatest for the Black Friday sales. So next chart, here we can visualize that there is a positive correlation between sales and customers. Stores with more customers tend to have higher sales. The impact of customers on sales increases as the number of customers increases. There are some outliers in the data, such as the store with the highest sales and the store with the lowest sales. So from the next chart, we can conclude that the world's population is not evenly distributed, and there are few regions with very high population densities. These regions have also large populations. So from the next chart, where we can visualize that the competition distance and the sales. So from this chart, the two variables are sales and competition distance. The dots represent the individual stores and the x-axis represents the competition distance in meters and the y represents the sales in euros. So next chart is the heat map. It is a heat map. So from this chart, we can conclude that the day of the week has a negative correlation indicating low sales as the weekends, and promo customers and open has positive. State holiday has a negative correlation suggesting that the stores are mostly closed on state holidays, indicating low sales correlation. Competition distance showing negative correlation suggests that as the distance increases, sales reduce, which was also observed through the scatter plot earlier. There is a multi-collinearity involved in the dataset as well. The features telling the same story like promo 2 since week and here are showing multi-collinearity. The correlation matrix is agreeing with all the observations done earlier while exploring through bar plots and scatter plots. Here is the pair plot between the different variables. So this chart shows the relationship between the number of customers, sales and the day of the week for a retail store. There are a few insights that can be found from the chart. There is a clear relationship between number of customers and sales. As the number of customers increases, so do sales. This is to be expected as more customers means more potential for sales. The day of the week also has an impact on sales. On average, sales are highest on Saturdays and Sundays and lowest on Wednesdays and Thursdays. This is luckily due to the fact that people are more likely to shop on weekends. There are some outliers in the data. For example, on Saturday, January 26th, there were only 200 customers, but sales were still relatively high. This could be due to a number of factors such as special promotion or event. So the EDA conclusion and the hypothesis validation. There is a poorer combination between customers and sales which is explanatory. Here it can be reduced that there were more sales on Monday, probably because shops generally remain closed on Sundays, which had the lowest sales in week, and this validates the hypothesis about this feature. The positive effect of promotion, not customers and sales, is observable. It is clear that the most of the stores remain closed during the state and school holidays, etc. etc. So next is the feature engineering and data preprocessing. So first here is the heat map of the data. Next is the handling of missing values. So in the dataset there is some missing values. So to predict the sales, we need to handling the missing values. After handling the missing values, we can see that there is no missing values left. Also outliers. So for handling outliers is So for handling outliers, it is another important step in feature engineering and data preprocessing for the Roseman sales prediction project. Outliers are data points that are significantly different from the other data points in the dataset and can have a significant impact on the predictive model. Here are some steps for handling outliers and performing outlier treatments in the feature engineering and the preprocessing of data. Identify the outliers. The first step is to identify the outliers in the dataset. You can use visualization tools such as box plots, scatter plots, or histograms to identify the outliers. Decide on the outliers treatment strategy. There are several strategies for treating outliers such as removing the outliers, winsorizing the outliers, or transforming the variables using logarithmic or square root transformation. Implement the outlier treatment strategy. Once you have decided the outlier treatment strategy, you can use Python libraries such as NumPy, Skippy, or Sklearn to implement the outlier treatment. So next is the for categorical encoding. I use one hot encoding. Alternatively, also you can use the label encoder from Sklearn to perform label encoding. So encoding categorical columns is an important step in feature engineering and data preprocessing for the data. Categorical columns contain values that are not numerical and cannot be used directly in predictive models. Therefore, we need to convert these categorical variables into numerical variables for using encoding techniques. So textual data preprocessing. Expand contraction. So split the text into the words and expand the contraction. Lowercasing. Using the lowercase method to convert the text into lowercase. Here we apply the lowercase method into the entire dataset. Removing punctuation and also removing URLs and words and digits, content digits, or let's say alphanumeric words. Removing stopwords and removing white spaces. Multicolority. Here is the all columns of the dataset, and here is a function that can calculate the variance inflation factor of all the data columns. So here is a data frame which denote the variance inflation factor column wise. Here is the value and here is the column name. So in the above table we can see that the variance inflation factor value for column promo 2 and promo 2 since here is higher, so we will drop either promo 2 or promo 2 since here and again check VIF value. So here we drop promo 2 column. So after dropping the promo 2 column, again check that. So now it is ready for the implementing machine learning models. So and next we will drop those store which cells is 0, assuming that the stores were closed temporarily, and this will help to train the model where more accurately. So here we drop the cells. So next is the machine learning model implementation. So for the first machine learning model, as we have two data sets, first one having 0 cells rows and another one excluding it. So we will both the data, take the both data and find the best fit model. First we will take dataset excluding 0 cells rows. So here we split the data into the trained and the test dataset while taking the test size of 20%. Then we take linear regression model and fit the trained dataset and checking the regression code, while we get that 67% as a regression score, and here is the linear regression coefficient and the intercept, and here we predicting the y value, and then we calculate the MAC and RMAC for the test prediction. Next is the shape and the limb model. So here we create the shape model, and here is the graphical representation of the shape model. And next is the lasso model. Mm, Here is the lasso model creation. And in lasso we taken the parameter for the grid search and the optimal value, so we can get the best fit model. So next we can see that the lasso 2 has a score of 0.17. And then we create the rich CV model, and here is also the parameters. So list of parameters, so that we can get the best parameters possible. So from here we can get the best score as 0.16. Next is the elastic net model. So here we also set the parameters so that we can get the best possible parameters. So and creating the elastic net machine learning model and fit the model and get the best score is around 0.17. So here next is the decision tree model. Here we take that sales model mean, and which is around the 6771. Next is the machine learning model 2 by taking the whole data set. Here the all the columns of the data set, and here is the dependent variable which is sales, and here is the independent variables where we drop the store promo to since here date sales, as there is a as those columns are not in use in model prediction. So here is the shape of the independent variable data set. So next is the train test split of the data sets, and here is again the linear regression model. So from here we can get the actual and the predicted value of the data set. Next is the calculating and printing the mean squared error value, and next is also the decision tree value where we can get the value is 79.794. Next is the random forest classifier. Here we create the random forest classifier model and fit the train dataset, and here we can create that get the point accuracy is 0.85. So next is the ADA boost regressor. So from this model we get a MSE score about this, and RMSE value about this, and the R2 score is 0.84. Next is the XG boost regressor model. So from this model we can get a R2 score of 90.9879. So we can conclude that the sales column contains 1,72,817 rows with 0 cells. So we created a new data frame in which we removed 0 cells rows and tried to train our model. We used various algorithms and got accuracy score around 74%. We were also curious about the total dataset including cells equals to 0 rows. So we trained another model using various algorithms, and we got accuracy near about 90%, which is far better than previous model. So we came to conclusion that removing cells equals to 0 rows actually removes a lot of information from the dataset, as it has 1,72,870 rows, which is quite large. So therefore I decided not to remove those values, and we got our best RMSE score from random forest model gradient boosting technique like ADA boost, XG boost, and we tried taking an optimum parameter so that our model does not overfit. At last, I will thank Alma for giving me this platform to represent my project. So thank you, Alma.